All right. What is your next step of this career?
The next step, if I decide to go that route, would be in full-time programming
Full-time programming.
within this line of work. This can also lead to different areas in the field, like we were discussing earlier about the possibility of moving enough spare parts out to our commercial customers that I may end up as a commercial parts person.
Okay. How does this job fit with your lifestyle? Like, does it?
Wonderfully.
Wonderfully.
For the most part, I work from 7 a.m. to 4 p.m. Monday through Friday.
That works.
Occasionally, when we have installations, I'll work on weekends, and I may be out of town for a week or two at a time, which is not a great big deal because the travel has been good. I've been to California, I've been to Pennsylvania, Arkansas, which doesn't seem to be too much to brag about in Arkansas, but I've been there, and several other states, and seen things that I wouldn't have otherwise seen without going to those jobs. So the travel's not a great big deal.
All right. What is the management style of the company?
Loose.
Loose.
It's very important to have a management that understands your capabilities and only gives you instruction when you ask for it.
Okay. And is there a dress code?
Only when you're on the job site.
Job site.
In the shop, we prefer that anyone in here wears steel-toed shoes if we're working with any heavy pieces. But we wear shorts and short-sleeve shirts, as you can see. On the jobs, you may be a little cold if it's a refrigerated job site, so you'll have to wear warm clothing. Sometimes it's unbearably hot.
And then, do you have any recommendations for myself? Other than wiring.
Find something that makes you happy.
That's what she said.
It doesn't matter.
That's what my recruiter said.
It doesn't matter what you decide to do, as far as anyone else is concerned. All that matters is that you're happy doing it.
And I'm doing the job right.
You can always learn, even if you don't know how to do the job, you can always learn how to do the job. I'll give you a brief history on me. Before I did this, I worked in commercial parts for heavy duty trucks.
Mm-hmm.
This sort of thing had always interested me. I fooled around with welding, a little bit of woodwork. I did some machine work in high school when we had a machine shop class, but I never did it as a job. And I decided one day I'd had enough of corporate micromanagement, and I quit without a plan, which is not a good thing to do. Don't ever do that. I don't recommend it at all.
Oh yeah.
But I told some of my friends that what I'd done, and they said, well, this is where we work. Maybe you need to come work with us.
Wow, okay.
So I came in for an interview, and he asked me what my interests were and what I knew how to do. I told him, and he hired me. And I started out just as a helper.
Mm-hmm. And then you learn the skills.
I helped other guys in the shop, and every hour I was not at work or spending some time with my family, I was in the library reading.
Oh.
I read everything. And whenever we weren't too busy in the shop, if we were in between jobs, or if I had some time on the weekend, I would come to work and I played with controls on our milling machine and a lathe. And I probably drove a couple of our electrical engineers a little bit crazy asking questions, but I picked up several different sets of drawings and started asking questions about what this symbol meant. What did this symbol mean? Mm-hmm. What does it mean when I see this? Where does this wire go in the real world versus what I see on paper?
Yeah, that's sometimes confusing, isn't it?
Now I do this, and I had no idea that any of this would make me happy. I had no idea. I knew that I enjoyed a little bit of machine work, but I'd never wired a single thing other than changing spark plug wires on my car, which I absolutely hated. And the first time I built one of these panels, I got thrown head first into a giant pair of panels that were going to control a giant conveyor system
Like
in
this?
Iowa. No, it's much bigger than this one.
Wow.
Much, much bigger. And once I worked through some initial frustrations with the drawings because I didn't know things, I loved it.
Okay. Cool.
So that's what I do, and that's,
Well, thank you for your time, Mr. Larry.
you're welcome. Find something that you
You
enjoy
love.
doing.
I enjoyed this. All right, Mother.
But these are your line drawings for wiring. And all of that basically begins with power.
Mm-hmm.
Let's see if I can find my power
So this
page.
is all for one big conveyor system.
Mhm. This is actually one of 3 that will be for this conveyor system. And your very first point of contact here is for your power, okay? 120 volt, 480 volt, 3-phase. And it all begins here.
So it all begins here.
Yes, sir.
That's the power supply?
This is where the factory will bring power in to this guy. That all gets distributed from this disconnect.
So,
This disconnect will have a handle on the outside of that big cabinet back there where you turn the power on and off. Anyways, it comes from here, gets distributed to these 6 blocks, and then further into smaller wires. These get distributed to different components that have 3-phase power that go to them. One of those is your 24 volt power supply over there.
so that's the power supply.
Mm-hmm. That changes your 480 volt 3-phase AC to 24 volt DC power. And that 24 volt DC power supplies everything up here, and all of this was necessary power along with the safeties that go to these drives.
Yeah.
But from here, the bulk of your 3-phase wiring will go to these line reactors, which, like I'm saying, they're just filters of a sort. If you have power spikes from your utility company, you don't want that going to your drives.
Yeah.
So this evens out the power spikes, so it doesn't fry your electronics in the drives. It comes from there, goes to these circuit breakers, then out of these circuit breakers, then to the drives.
So like you protect the drives.
And from your 24 volt power supply over here, that supplies power to each of these input and output cards, either through this module, which has 24 volts going into it, and into this communications module, which is part of your Ethernet system here. And then you have safety input, safety output, regular input, and regular output.
How long did it take you to put all this together?
Assuming all the parts are here and on the shelf, and I have all the wire and all the drawings at once, I can do this in about a week.
A week.
And maybe 45 to 50 hours of time. And all of these are very similar in their construction, no matter what kind of control panel you happen to be building. If it's for a commercial application, it will have 3-phase power coming in. That will get converted either to 120 volt AC power, and you use that to power your laptop plugs and things like that.
Yeah.
So whenever you're
So you plug
programming,
in the laptop to the PLC.
exactly, and you can keep your laptop charged up while you're programming. Because sometimes that may take a day or several days or weeks to do.
Just depending on the project.
Yes.
This is obviously a big project.
Yes, and you know, programming, as you know, it can be anywhere from 20 or 30 runs of ladder logic to 2,000 or 3,000 or 10,000.
Yeah.
and from these guys, your inputs and outputs, and you're familiar with those. Your inputs are just 24 volt DC signals that come back and tell your program whether something's in the way of a sensor or not.
Yeah, I learned that from the Kia guys. You can have like thousands of line of code.
Oh yeah, absolutely.
How many lines of code are for this project?
That would be a good question for Joan. She's a programmer, but she's kind of busy right now.
Oh, she's
with
busy.
another
I would say
project.
thousands.
Thousands
You would say thousands?
Yeah.
for all this equipment.
Mm-hmm. The conveyors that these guys, this one and the other two, will be involved in controlling the process and determining the leads. On the job, we'll have 3 layers of these, sometimes 2 layers of these guys. And boxes of product will come down and we need to change
Or
the direction.
patties
Only boxes on these.
on these.
Mhm. The boxes can come down and touch this sensor or that sensor, depending on which direction they're coming from. And if that particular box needs to go down here, these bells will pick it up and transfer it to this conveyor, which takes it in a different direction. Or in that direction.
Sure.
And the same for one of these guys. This is called a right angle transfer. System also.
Where did you get your education from?
Mine on the job.
On the job.
And the public library.
So you went to the public library and read technical manuals?
Mm-hmm.
Cool.
I've studied mechanical engineering, aerodynamics, hydrodynamics, and associated math, along with some electrical engineering in technical journals at public library. Anytime I've ran into situations where I simply did not know the answer and no one around me could give me an answer, or they didn't know, I found out for myself.
Oh, okay. That's cool.
What's your next question?
What's my next question?
The scope of skills required to do work like this?
Yeah.
Maybe? That's wide and varied. If you're specifically a panel builder, there's some small amount of drilling and tapping holes.
Yeah.
And doing the layout for your components.
I could learn how to drill and tap.
Yeah, it's not difficult.
It's not difficult.
It's chiefly attention to details. When I'm wiring, and I'll show you just a few things here. Let's pop one of these covers off,
Oh, okay.
and you come have a look.
So there's an Ethernet cable in there.
See how there's no exposed wire here, here, or here,
Yeah.
or down here on the 480 volt connections, either into or out of.
Yeah.
That is a small detail, but it is extremely important, because as these things get put out into the field and some very rough hands touch them continuously over and over for the next 3 or 4 years, if you have exposed wires or stray strands that didn't make it all the way inside of the connection, those could contact each other. In the case of these 2 guys, that could cause a direct short.
Which could damage this.
Which could damage things, or it could cause great big headaches, because sometimes you can't see that one little strand of wire. So it's very helpful if you are very OCD about how much of the insulation you remove and if any of it's visible outside of the connection. You always want to make sure that you have enough inside the connection to make a good connection, but you don't want anything shown outside. That's one small attention to detail. And you got cable routing like this. There's such a thing as inducted current. That's when you have 3-phase AC power. You know, each of these, they call it 3-phase because they're out of phase, out of sync with one another, right?
Right.
This creates a very strong magnetic impulse or field, especially when you have a bulk of it like this.
Bulk of wire.
So if you have unshielded wires like these for your safeties, you can't have these guys sitting next to each other, and if you do, you'll get inducted current into here and it could trip a safety,
Yeah.
which wouldn't allow it to run. You could also get some crosstalk. So things like this, learning to build a wiring harness that's not just pretty but secure and functional. You still need to be able to trace each wire down to each point
Like that.
and identify it. But it,
With the that. So 3, and then you look down at 3.
Mhm.
That's a good tip.
yeah, and if you have a problem with that cable, you can ping each wire up or each end of it to find out if there's a problem with the conductor.
So you find 3 too.
Yeah. You'll see the same things here when you're laying out your components on the back plane.
Mm-hmm.
Always leave enough space so that your wire labels are easily seen whenever you put the covers on, but these guys are going to get white covers on here. You'll always be able to see that. When you have a length of airspace, the conductors, each wire is a conductor. A length of airspace where conductors are going to be exposed or hanging in midair, you want to make sure that they're not touching another sharp edge.
Yeah.
There's some vibration, you could cut through that and get a little sparky spark happening, which is never a good thing.
Are you talking about the exposed wire?
Mm-hmm.
Yeah.
And your layout and wiring as a whole, I don't know if you've noticed, but you don't see any of this blue and white and green overlapping with any of this white anywhere. So whenever you lay your components out, you have to be mindful of where you're going to route your wires in the panel, so you don't have these guys overlaying one another. Sometimes it's unavoidable, like with this contactor. All right, contactor is powered by a 24-volt coil.
Yeah.
Just a little solenoid in there that opens and closes some contacts. When you've got 3-phase power going into it and you've got a DC coil in it, you're going to have DC and AC close together, but only for an inch or two. And if at all possible, if you look, you can see whenever these wires cross, they're mainly at a 90-degree angle. That's good. Side by side at that.
Mm-hmm.
That way you don't get inducted current. The other way you will. The other things you may have to do or not do, depending on what kind of cabinet shop you work in, is if you have any penetrations in the cabinet, you may need to knock holes in the bottom for access to bring cables into the cabinet. You may need to be able to use a grinder and files and other hand tools to cut a hole in the side of it for access, or a hole in the door for your touchscreen, for your HMI.
Yeah. I know what you're talking about.
Yep, and poke holes in the door to put your buttons in.
Alright. Would you say that's good enough, Mother?